theta would be here? Pi over 6, right? Okay, exactly right, Alyssa. Very good, okay. So we could just say here, we can just figure out from this problem that since the sine of theta is 1/2, there's a very good chance then that theta could be pi over 6, or in other words, 30 degrees, right? And so we could then just say, then this must be talking about a 30, 60, 90 right triangle. We could just draw that triangle, okay? And in fact, let's just go ahead. That's kind of the first step we're going to do here is we're going to, okay, create a triangle that has that angle theta in it. And of course, we're going to create a right triangle because our trig ratios are relationships within a right triangle. So create a right triangle with angle theta. Okay. All right. And so I'll do that right here. Pen's dying. Okay, it doesn't really matter how well you draw the right triangle because we're just going to put our angle theta in there somewhere. It doesn't really matter which acute angle you pick. Okay, I probably should have chosen the top one though, just for like the sake of how it should look, but that's okay. Okay, and then since we know that the sine of that angle theta has got to be 1/2, and we also know, according to SOHCAHTOA, sine is opposite over hypotenuse, then the side or the leg opposite theta has to be what measure? 1, right? And then what does hypotenuse have to be? 2. Okay. Now, granted, it could be other things, right? So, for example, the side opposite theta could be 2, and this could be 4, right? As long as the ratio simplifies to 1/2. So it doesn't have to be exactly 1/2. It could be other numbers. But since, we want just the easiest way to go about this, we'll just use the 1 and the 2. But again, it could be like 2 and 4. It could be 3 and 6. As long as it simplifies back down to that ratio of 1/2, we're good. All right. And then by the Pythagorean theorem, then we can find this missing third side if we want to. And why might we want to find that missing third side? Well, if we know that the sine of theta is 1/2, and we want to find all the other trig functions, we're going to need to know all 3 sides of that triangle. Okay, so we're going to want to find that third missing side here. Okay. Sorry, I misread this up there. So again, we created a right triangle with angle theta, and then we labeled the sides using the given ratio. Okay. Right, because that's what sine of theta equals 1/2 means. So we're just using the given information there. And then, like I said, step 3, we need to find the missing side, and then we're good to go, because then we can find all the other trig ratios. Okay. So Pythagorean theorem here, right? 1 squared plus, I don't know, we'll call this x squared equals 2 squared, and so you get 1 plus x squared equals 4, and so we can subtract 1 here, x squared equals 3, and so x equals the square root of 3, which again we shouldn't be surprised by. We know this is 30, 60, 90 right triangle. Okay, I just wrote it, I didn't draw it very well, but it's going to be a 30, 60, 90, so the third side should be root 3. Okay. And so now we have all 3 sides, and we have our angle theta there. We can now just evaluate all these other ones. So cosine is adjacent over hypotenuse, right? So adjacent, root 3, over hypotenuse of 2. So there it is. Tangent of theta is opposite over adjacent. So opposite theta is 1 over the adjacent leg, root 3. Or we could say root 3 over 3. Right, again, if we rationalize it. Cosecant is the reciprocal of sine, right? Okay, I write it that way on purpose, so that way it helps me remember which one's the reciprocal of which. So it's 2 over 1, or again, just 2 if you like. Okay. Secant of theta, then, the reciprocal of cosine. So 2 over the square root of 3. Or again, if you rationalize, 2 root 3 over 3. And then cotangent is just going to be root 3. Okay. And so there it is. Okay. Given one trig ratio, we can find all 5. Okay. It gives us a kind of like, that's enough of a setup to find all the other 5 trig ratios because they're so interrelated like that. Okay? Questions on any of that? Pretty easy? Alright, I'm going to have you guys try one. Try. So, same kind of situation. Let's say we're given that tangent of theta is equal to 3. Okay? Find the other 5 trig ratios. Okay? So of course, if tangent of theta equals 3, that's the same thing as the fraction 3 over 1 there, right? Because for tangent, you need an opposite leg over an adjacent leg. So really, just a plain old 3 is not as helpful as writing it as 3 over 1 there. Okay, let's go ahead. Give it a go. What? Say one more time, sorry. Right. So this is not one of our special right triangles, but you can still arrive at the missing parts by using the vector theorem really quickly. So it doesn't match to one of these, but we can still, the trig ratios still apply, just not the known ones that you would use if you. Does that make sense to you? So what you want to do is just you want to draw and label this particular triangle using the fact that again tangent is opposite over adjacent. So label the opposite leg from that wherever you put theta as 3, the adjacent leg is 1, and then proceed from there. You mean the first time we went through it? We'll take maybe later in class. But I'm thinking we should just form it. Okay. So there's our triangle. Right? There's theta. theta, and so we want to set up our ratios here, okay? It's very important that we calculate these things accurately, right? If you make a mistake, that can cost you because you're going to see like you're going to get a bunch of them wrong and if you make a mistake there, okay? So just be careful. So sine would be 3 over the square root of 10, okay? Or, again, rationalize 3 root 10 over 10. Cosine is going to be 1 over root 10, or, again, rationalize root 10 over 10. Okay? Tangent, we know, right, it was 3 over 1. And then, therefore, we also know we would know cotangent without even having to draw the triangle. It's just the reciprocal of that. And then the secant is root 10, and then cosecant is root 10 over 3. Okay? Questions on any of that? All right. 2 more things I want to show you here, and then we're done. I'm going to try and squeeze them in here on the bottom. See if it works. I think it should. Okay. So, other little like twists that like can be thrown around with these kind of problems. For example, we could be given that cotangent of theta. Cotangent of theta is equal to like x plus 2 over 7. So we're going to throw in a variable here. Okay. We can be given this. But the idea is still the same, right? I mean, let's just kind of proceed as we normally would and see what happens, right? See what changes. So, and again, we're trying to find the other 6 trig, or find the other 5 trig functions. So, find the remaining, trig functions here. Okay, so again, we'll still put the theta into our right triangle here. Okay, cotangent, according to Chosha cow, that's where it falls apart there, I guess. There's 2 C's, right? But cotangent is adjacent over opposite, right? So that means then it's the reciprocal of tangent. Tangent's opposite over adjacent, so then the reciprocal will be adjacent over opposite. So the adjacent leg is going to be x plus 2, and then the opposite will be 7. Okay? And so then let's say we just want to find sine, cosine, and tangent here. And we'll just do sine, cosine, and tangent because, well, once you have sine, cosine, and tangent, you can just do the reciprocals to get the rest of them, right? So we'll just do sine, cosine, and tangent for this, just to kind of speed things up a little bit. Tangent's easy, right? It's just a reciprocal of cotangent, so it's 7 over x plus 2. We don't even have to do any real work there, just flip it. All right, but then for sine and cosine, we run into some issues, right? Sine, for example, of theta, it's the opposite, so we got 7 over, but we don't have the hypotenuse. And so we find the hypotenuse the normal way that we usually do, right? We just square both legs and add them up. So it'll be the x plus 2 squared plus 7 squared equals, and then our hypotenuse there, I'll call it just c, I guess, since you're already using x. Okay? And then at this point, it's kind of like, ooh, we're going to have to square this thing, I guess, but really all we need to do is just get c by itself here. Right? All we need to do is just get c by itself here. So really what I can do is just square root both sides at this point, right? Because I'm not really going to be able to add, I won't be able to get a single term here and then take the square root of it. I'm going to get kind of like some mess in there. So what I'm just going to do is you can just leave it like this, okay, and just say that c is the square root of, x plus 2 quantity squared. I guess I'll say that's plus 49 there. Okay, like that. If you wanted to, you can square out that x plus 2 and then add the 49, okay? But it's still going to be the square root of some quadratic thing, okay? Some quadratic. And so then sine of theta here would just be 7 over the square root of the quantity x plus 2 squared plus 49, right? Like that. That's going to be how we write that ratio because of the different, variables and stuff in there. That's how we're going to write that. Okay. And then cosine, well, it's going to be the same idea. So it'll be the adjacent, so x plus 2 over, and then again our hypotenuse, the square root of x plus 2 squared plus 49. secant will just be the reciprocal of cosine, and then cosecant would just be the reciprocal of the sine there. So I don't want to spend too much time on that. There it is. Okay, so no difference. It's just that we have some variables thrown in, and there's less simplification, right? It's just a little bit less simple. It's more complicated looking. That's all. Okay. Questions on any of that? Still finding the hypotenuse. Still just using your triangle to evaluate the rest of them, though. Okay. And one other kind of problem that I like to throw in, okay, is and it's similar to this, but just like a bit of a different twist to it. Okay, it's when one other question we could be asked is something like to find the trig ratios. Okay, given the terminal side of angle theta goes through, okay, let's see here, -3, 4. We find the trig ratios given the terminal side of angle theta goes to the point -3, 4. So now we are jumping back to the coordinate plane right here, right? No coordinate plane. We're just kind of like in space, you know, kind of thing, in some geometric space here. All right, no coordinates attached to this whatsoever. Same idea for these earlier ones. Okay, right? We just kind of drew a triangle in space, but now we're talking about coordinate plane. So it's helpful to maybe sketch this out on the coordinate plane, right? And since we're at the point, we're going through -3, 4, we can maybe highlight the second quadrant, because that's where that point -3, 4 will be. Okay. And so, I'm just going to eyeball it. So 1, 2, 3. Okay. So the point -3, 4 would be, according to the way I kind of drew it here, like roughly right there. Okay. And so the angle theta, right, that's the terminal side of angle theta, so that's like, kind of like the ending side, right? When we talk about angles in the coordinate plane here, we have the origin is the vertex, the pointy part of the angle, right? We start on the positive side of the x-axis, and the angle is supposed to kind of open up like this, right? And that would be theta. But of course that angle theta, right, it's obtuse. It doesn't create a right triangle, right? You can't have a right triangle with an obtuse angle theta. Right? And we ran into problems, we ran into this situation, right, when we were trying to find the coordinates on the unit circle. Okay, and we were trying to find, sine, cosine, and tangent angles that are like in the second quadrant there. Well, we, instead of using this angle theta, we use the reference angle right here. Okay? So instead of using this as our theta, we're actually going to use this theta right here, that reference angle off the x-axis. And that allows us to then create a right triangle here. Okay? And so we know some of the labels too. For example, what is the length of this leg of this right triangle? 4. How do you know? The y-coordinate's 4, right? So the height off the x-axis is going to be 4. What's this length right here? It's going to be 3, right, for the same argument. And so then, because we know this kind of right triangle, what's the hypotenuse going to be? Right, it's got to be 5, because it's a 3, 4, 5 right triangle. Okay. And so we can go through and find all of our trig ratios. So sine of theta, cosine theta, tangent of theta, cosecant theta, secant theta, cotangent theta. Okay. So again, we don't want to use this angle theta here to help us evaluate it. We're going to use this reference angle theta, okay, which is just going to allow us to create find those triangles there, find those measurements, I'll say. Okay. So sine is opposite 4 over hypotenuse 5, so it's just going to be 4/5. Cosine is adjacent, so 3 over 5. Tangent of theta is opposite over adjacent, so 4/3. And then just those reciprocals. 5/4, 5/3, and then 3/4. Okay. Now, remember, when we use the reference angles in trig, right, when we were talking about when we were evaluating on the unit circle and stuff like that, and we use those reference angles, we had to watch out for the sign. That is whether they were positive or negative, the SIGN sign, right? In what quadrant are we located here? 2. So in quadrant 2, what trig functions are positive? Sine and cosecant, and that's it. So everything else here we have to make negative, okay? Sine and cosecant will be positive, but we're going to make everything else negative, okay? That's how we can kind of get away. That's how we can kind of get away with using that reference angle. The reference angle works as long as we then go back and just fix the signs, the SIGN signs, okay? Positive or negative. If you don't want to have to think about this, one other thing that you could do here is instead of labeling this side of the triangle as a positive 3, you could label it as a negative 3 if you wanted to, because it's like, you know, like the negative 3 x coordinate there. And then this 4 would be a positive 4 still because it's going positive in the y direction. And then 5, the hypotenuse, will always be positive. And that will also take care of it, right? For example, cosine is negative 3 now over 5, and that's what we end up with. Secant would be the reciprocal, and tangent as well. Tangent is 4 over negative 3, which again would simplify to negative 1/3. So if you wanted to take care of it that way, you could as well. Just, you know, label this as a negative 3 since you're going left 3 there, if you want. But you don't have to do it that way. You can just take care of the signs at the end. Okay, questions on any of that? All good? All right, so I'm going to get you guys started on your homework here. So here we go. All right, so page 316 in the book. I'd like you to work on number 13, 15, 25, 25, 27, 69, 70, and 73. Okay, and don't forget the problem set number 1. Okay, that's also due Monday. Okay, graded for correctness. All right. Let's get started on one of those things there if you haven't, especially if you haven't finished that problem set. You might want to get started there.